All right, coming into this, I wanted to come back and talk about example 8 just a little bit more before we moved on. And most of what I wanted to talk about is this idea of this extraneous solution that, you have to be careful of. So suppose that, all right, so suppose that when we were looking at this, maybe you didn't realize it. You canceled and you got down here to the end and you forgot that this sign of x equal to 0 was not allowed. What you also have to kind of think about, kind of way back here in the beginning of the problem, is that you should look at the original problem and you should say, what's the domain of that original problem? That in the original, we have basically two places where you have a denominator of sine of x. You have it right here, and I circled in red, and then cotangent is also a hidden fraction because it's a quotient function, and it also had sine in the denominator. And so coming up here in the yellow highlight, solving where sine of x is equal to 0, we know that that can't be. None of our solutions can be 0 plus pi k. That's not in the domain. So if you forgot that and you get down here to the end and you're listing solutions from this in here, and you have like 0 and pi and negative pi and so on, that you have to recognize that those are not in the domain. So that's the other thing that we talk about here, is this idea that you should check your domain just to be sure that you have not, created any extraneous solutions in the solving process. All right, so now let's take a look at example 9 and example 10. Just a little bit different, kind of looking at it. You may have seen this in the other videos that I've asked you to watch, that this idea of get 0 on one side. Really going to stress that. Get 0 on one side. So the first thing I do, I'm going to move everything over. I'm not even going to do any substitutions here. I'm just going to get it over on one side. Now I'm also going to recognize, second thing you look for a GCF. So when I look at this, I have two different trig functions, but it doesn't bother me because I have a GCF of tangent of x in both of these terms. So we do want to pull that out and then put it in our factored form, minus 1 equal to 0. We do not want to, and this is going to be the temptation that you have, is that you guys are going to want to divide. I'm going to say don't divide by tangent of x. That if what we did up here, canceling, creates extraneous solutions, extra solutions, then dividing something out makes you lose solution. It kind of goes the other way. So never divide by the variable. Make sure you move everything over, get 0 on one side, and factor. So then we take a look at this zero product property. We're going to make this into two separate problems to solve. Tangent of x is equal to 0, or square root of 2 cosine of x minus 1 equals 0. Now this one has the second one is a little bit of algebra, so let's go ahead and do it. I'm going to add 1 and divide by square root of 2. And I'm going to recognize that that number is the same as square root of 2 over 2. All right, so now we're going to go into our 0 to 2 pi kind of solutions first. I kind of always start that way, and then I expand into what they'd ask me to do. So tangent of x equals 0. Remember that tangent is the ratio of y over x. There's a couple different ways you can do this. You can think of it on the unit circle. I have a tendency just to think of the graph itself for tangent, and that's going to be equal to 0 at 0, and then the period is pi. So x equal to 0, x equal to pi, x equal to 2 pi, and so on. And because it says all solutions, I'm going to be like, oh, hey, it happens starting at 0, and then every time you go one period away from 0. So that's going to be that portion of it. Now over here, these are the ones that you have to be careful of. There will always be two solutions in the first rotation. Cosine is positive. Remember, all star trig class. That cosine is positive in quadrant 1 and quadrant 4. So I need the angle in quadrant 1 and quadrant 4. I need to think about my reference angle, what family I'm in, and this is going to be pi over 4. And so quadrant 1, x would be pi over 4. Quadrant 2, or actually, I'm sorry, quadrant 4x, remember going all the way around would be 8 pi over 4, so that would be 7 pi over 4. And we do the coterminals to get the all solutions. So this one was fairly straightforward. It has 3 equations to represent the solution set of all the possible answers that we have. All right, let's look at example 10. Now, this may be a symbol that you haven't seen before, but we're kind of making a joke here. It says find all solutions such that, and it kind of looks like a little like W, or like maybe, you know, what's the guy that lives in the sea that has a little forked thing, Aquaman, you know, that kind of thing. But that actually is a Greek letter, and it's the Greek letter psi. And so we're just throwing that in for some fun, just to kind of, you know, show you that there are other Greek letters you can use for the angles. If it bothers you, you can certainly just think of it like an X, because that's really all it is. But we're going to do the same thing here. And then this is also something that when you're solving these, does it really matter what this variable is? You can be like, hey, let's just call it X. And if you prefer writing it, that's perfectly fine. If you're happy with writing the little pitchfork looking thing, that's fine too. Either way that you go. Now, again, same thing. We're going to notice here we have quadratics, just like we have before. I'm going to move things. I'm actually going to move it over to the same side this way. So I'm going to have 3 sine of x minus 2 cosine squared x is equal to 0. Get your 0 on one side. Now, our problem with this one is that we have 2 different trig functions. But that doesn't bother me, because I'm going to remember that the Pythagorean identities, if there's a square there, I can substitute that out. So I'm going to make a substitution for that. So this is going to become 3 sine of x minus 2 parentheses 1 minus sine squared x equal to 0. At that point, I'm going to do a little algebra. I'm going to go ahead and distribute. So 3 sine of x minus 2 plus 2 sine squared of x is equal to 0. Now you kind of see why I decided to move this to that side. And that was because I was planning ahead. I wanted to have a positive squared function. I'm going to reorder this now. Sine squared x plus 3 sine x minus 2 equal to 0. You typically, whenever you can, you want to make sure that this first quadratic term is positive. And if it's not, that's okay. Just multiply both sides by -1 and fix it so that it is. It makes it easier to factor when we have it set up like that. Now, the same thing, I think that you guys can handle the guess and check. We know that the first term has to, these 2 terms here, if I do 2 sine of x and sine of x, right? The first 2 terms have to end up being that one. Now, here we have a choice. We need to have 2 numbers that multiply to 2, but that in the combination, when we do the inner and the outer, we have to end up at 3. So I pretty much know that, like, if I put the 2 here and the 1, like, that would be wrong, because that would be a 2 and a 2, and 2 plus 2 does not equal 3. So let's undo that. It's, you know, the whole guess and check thing is there's only so many things that there are. So let's try the 2 here and the 2 there. And, oh, wait a minute. 2 and a 1. My apologies. So I would have a 1 sine x and a 4 sine x. And this has to be positive. This one has to be negative. And we can check and make sure that we got our signs right. So we get it to our factored form. We're going to turn it into 2 problems now, zero product property. 2 sine of x minus 1 is 0, and sine of x plus 2 equals 0. Now, I'm just going to move a couple things around here, mostly because, you know, I can. You know, you get mad at me when I do that. But this way I can fit everything into this little section. So I'm just going to kind of move things over and up so I have some room. All right, so we take a look here. We're going to solve each of these individually. This one would be sine of x equals 1/2. Sign is positive. I need a quadrant 1 and a quadrant 2. We did this earlier, so hopefully you're going to be very, very fast. Now, be careful here. I'm going to go quadrant 1, quadrant 2, pi over 6 family, pi over 6, 5 pi over 6 initially. However, this is not going to answer the question that they asked me, because you always have to make sure you read what they've asked and read the question. They want the answers to be in between negative 4 pi and 0. So while those are solutions, they're not the solutions in the correct window. So we're going to come over here, our actual solution set, and I'm going to start building that, and I'm going to basically go, hey, I need to do coterminals, but I need to go backwards in order to get them. Sometimes I might look at this negative 4 pi and put it in terms of a denominator of 6. So that would give me negative 24 pi over 6. So I'm looking for things between 0 pi over 6 and negative 24 pi over 6. Now remember that when you're subtracting 2 pi, we're subtracting 12 pi over 6 each time, right? So pi minus 12 would be negative 11 pi over 6. Negative 11 minus 12 would be negative 23 pi over 6. And then we would be too small to keep going, because that's why we did our little target up there. Do the same thing with the other angle. 5 pi over 6, 5 minus 12 is negative 7 pi over 6. And then negative 7 minus 12 is negative 19 pi over 6. We're still in the window, so we get those down. All right, then we go over to the next equation. And in this one, you solve it over. Sine of x equals negative 2. And then here's where you have to be smart. Remember that the range of sine is negative 1 to 1, which means that no ratio, no sine ratio, can equal negative 2. And so that's just not possible. And so there are no solutions from this factor. So we can go ahead and close out our solution set, and these are going to be the only solutions that I have. All right? All right, so that gives you a good overview of kind of what's going on with our solving equations. You do want to go ahead, I think you can do these before you watch the remaining video. So this example 11 right here, you're going to try on your own. I'll put a separate video up that does the solutions, or I think these are simple enough. I'm just going to do the key and have that in there. Just check your answers as you go. You can email me if you have any questions. But once you finish with this example 11, make sure you watch the final video, which is in the video page over here. Videos for Wednesday, the Solving Trig Equations 3. That's going to do a couple of more complicated examples that might come up later on in calculus and so on. So it kind of gives you like these are the, what I would call the, when you're doing the video game, you're at level 200 at this point. These are the super serious ones. They're very complicated, but I really would like you to just, expose yourself to them. So watch that video. All right, so again, make sure you finish this example right here, example 11, watch the video, and then that will finish up Wednesday's lessons.